Hello dear children, I hope you're all doing great today. Welcome to physics class. Well, today we are all going to that magical world where maths meets motion. Yes, it's time for equations of motion. So today we shall have a discussion on three powerful equations of motion which help the scientists to touch the rocket space as well as to keep the cars in racing track. So children, one thing you remember that equations of motion are valid only for uniformly accelerated motion. And this equation of motion are not valid for non-uniform accelerated motion or variable accelerated motion. So in order to discuss this variable accelerated motion, you have to depend upon the calculus method which you will be learning in the higher classes. So today let us have the discussion on equations of motion. Okay, so equations of motion. First equation of motion, which gives us the relation between the velocity and time. First equation of motion. First equation of motion. This gives the relation between velocity and time. And this is how the equation is being written as. The relation between velocity and time is given as v is equals to u plus at, where v is final velocity, u is initial velocity, a is acceleration and t is time. Consider a body moving with uniform acceleration whose initial velocity is u and after a time t, its velocity be changed to v. Then we can say that from the definition of acceleration, we have acceleration is nothing but change in velocity. Change in velocity upon the time taken. Change in velocity upon time taken. So acceleration is indicated with the letter A, change in velocity. Children, I told you that the body initially starts with velocity u. The initial velocity be u, and as the body is accelerating, velocity goes on increasing, its final velocity be some v. U the initial velocity, v the final velocity. What is the change in velocity? V minus u. So change in velocity is v minus 2, and this change was brought in a time t. Hence, acceleration A is equals to v minus u by t. Bring this t the other side, children. Then at is equals to v minus u. Minus u, if you bring to the other side, u plus at is equals to v, or rearranging the term, we have v is equals to u plus at. This is the first equation of motion in kinematics. So children, what is the formula? V is equals to u plus at, where u is initial velocity, v is final velocity, t is the time limit, and a is the uniform acceleration. So children, try to remember this equation, that is v equals to u plus at. Now moving to the second equation of motion. The second equation of motion is something like this. Second equation of motion. This brings us the relation between displacement and time. The relation between displacement and time. So how the relation between displacement and time is given as S is equals to ut plus half at square. So children, what is the formula? S is equals to ut plus half at square. Suppose if you consider a body moving initially with velocity u, and if it is being uniformly accelerated in a time t, its velocity we change it to v, and as long as its velocity, before its velocity changes to v, it covers certain distance or displacement given by s. I repeat, consider a body moving with initial velocity u, and it is, let it be, suppose that it is accelerated, uniformly accelerated for a given time t. Then meanwhile this body covers a displacement s. Then s is equals to ut plus half at square. Let us try to derive the same. So children, we know that average velocity is given by average velocity. If u is the initial velocity and v is the final velocity, two values I have given, u is the initial velocity and v is the final velocity, then the average of u and v is given by u plus v by 2. Average velocity is given by u plus v by 2. Let us indicate this average velocity as something like v average, some symbolic notation. Okay, average velocity v average is equals to u plus v by 2. Isn't it, children? So now we know that speed equals to distance by time. Speed equals to distance by time, or velocity equals to displacement by time. As we know that velocity is equals to displacement by time, I can write displacement is equals to velocity into time. So what is the formula, children? Displacement can be written as velocity into time. So let me write it. Displacement is equals to velocity into time. But here this body is moving with two different velocity. At the beginning it has velocity u. The initial velocity at the beginning case was u, and the final velocity at the end was some v. Then the average velocity is u plus v by 2. So instead of saying either initial or final, let us take the velocity as average of the two. Hence average velocity, what is this, children? It can be written as, displacement is written as average velocity into time. Displacement indicated with the letter S, average velocity indicated with the letter V, A, V, G, and time at some t. I hope you are getting me, children. So displacement equals to velocity into time. Because it has two different velocities, I took the average of the two. So average velocity into time. Displacement indicated with the letter S, average velocity indicated with the letter V, A, V, G, and time with t. So based on that, I can write S is equals to, instead of V average, I can replace with U plus V by 2 into T. Isn't it, children? So S can be written as U plus V by 2 into T. So now moving back, in the previous case, I told you that V can be written as U plus AT. Instead of V, wherever I find V, I can replace it with U plus AT. So let us substitute the same. Then S will become, S is equals to U as it is. Instead of V, what I can replace, children? Instead of V, I can again replace with U plus AT. V is nothing but U plus AT upon 2 whole into T. Get it, children? So this U as it is plus as it is, instead of V, I replaced with U plus AT whole upon 2 into time. So now after simplifying this U and this U, so just open the bracket, U plus AT by 2 into T. U plus U, how much, children? 2U. Very good. 2U plus AT upon 2 into T. Now This 2 is common for both the variables. 2u by 2 can be written as 2 gets cancelled. For your simplicity, I'll rearrange the terms like this. This can be written as 2u by 2 plus at by 2 whole into t. This 2 and this 2 cancel. So what are you left with, children? U, here 1 by 2, at and into t. See, let me write here once again. So what is this? S is equals to u plus at by 2. I'll write at by 2 as half at. This u, I wrote it here. This 1 by 2, I wrote it here. And left over at here. And what is left? T. Hence, bringing the t inside, this will become u into 2e is ut plus half a. T into t is t square. Hence, the formula S is equals to ut plus half at square. So, let us read it once again. What is the value, children? S is equals to ut plus half at square. This brings the relation between displacement and time. Okay, children. So, what was the first equation of motion? That brought the relation between velocity and time, that v is equals to u plus at. Suppose if the body is at rest, initially the body begins at rest condition, then the initial velocity beginning is 0. Then in that case, v is equals to at. Okay, children. Suppose if the body is moving with uniform velocity. Uniform velocity means no acceleration. Whenever the body is moving with uniform velocity, that means no acceleration, that is a equals to 0, then v is equals to u. So, two cases I told you. Whenever the body begins at rest, whenever the body starts from rest, whenever the body starts from rest. In that case, you have u is equals to 0. In that case, you have u is equals to 0. So, substitute u equals to 0, then your equation will turn as v is equals to at. And case 2, whenever the body moves with uniform velocity, when body moves with uniform velocity. In that case, we have initial velocity is equals to final velocity. Whenever this initial velocity is equals to final velocity, then we have acceleration is 0. Same velocity, so no acceleration. Acceleration is equals to 0, then u is equals to v, or a equals to 0 or u is equals to v. So, whenever the body moves with uniform acceleration. So, what is the first equation of motion, children? It tells us something regarding the relation between velocity and time, and that is the formula is v is equals to u plus at. And whenever the body starts from rest, initial velocity u equals to 0, then the equation is turned as v equals to at. And whenever the body moves with uniform velocity, then no acceleration, a equals to 0, that means v is equals to u. Second equation of motion tells us the relation between displacement and time, and the formula is s is equals to ut plus half at square. S is equals to ut plus half at square, where s is displacement, u is initial velocity, t is time, a is acceleration. Here also, suppose that if the body starts from rest, when body starts from rest, then what is the condition, children? Whenever the body starts from rest, initial velocity u is equals to 0, and replacing u equals to 0 in this equation, anything into t is 0, so s will equals to, this is 0, then half at square. Whenever a body starts from rest, then u is equals to 0 and s is equals to half at square. And the second case, whenever the body moves with uniform velocity, body moves with uniform velocity. then what is the condition, children? In that case, we have no acceleration, that is A is equals to 0. Whenever the body moves with uniform velocity, no acceleration, so A is equals to 0. Hence, substituting A equals to 0, this total term will become 0, then displacement S is equals to UT. Okay, children? So this is the second equation of motion. Now moving to the third equation of motion in kinematics. Okay, this relation, third equation of motion, gives us the relation between the velocity V and displacement. Velocity V and displacement gives the relation between velocity and displacement. Okay, children, so this relation is something like this: V square minus U square is equals to 2AS, where V is final velocity, U is initial velocity, A is acceleration and S is displacement. This brings the relation between initial velocity, final velocity and displacement. The same case, let us consider a body moving initially with velocity U, and whenever some force is acting on that, the body is being accelerated and uniformly accelerated with some A, and as long as it is being accelerated, its velocity is changed to V after covering the displacement S. So hence V square minus U square equals to 2AS. In order to understand the same properly, so let us consider this. So earlier case, we know that the displacement is given by average velocity into time. Displacement is equals to average velocity into time, that which we have already discussed in your previous concept. So here it is. We know that displacement equals to average velocity into time, isn't it, children? So displacement equals to average velocity into time. So displacement is indicated with the letter S. Average velocity, average of two different velocities, one is U, one is V. What is the average of these two? U plus V by 2, that is U plus V by 2 into time t. Hence S is equals to U plus V by 2. Okay, children, again from the first equation of motion, look here, we have, what is the first equation of motion? We have V is equals to U plus AT. Let us replace the same. Since we know that, since V is equals to U plus AT, I can replace this with like this, something like this. I'll write it. We know that V is equals to U plus AT. Bring this U the other side, then V minus U is equals to AT. V minus U is equals to AT, or T is equals to V minus U by A. T is equals to, what is that, children? V minus U by T. Or else, in other form, we know that acceleration is defined as change in velocity by time. Acceleration A is equals to change in velocity by time, that is V minus U by T. So interchange the term, bring the T here and A to the other side, then this become interchanging the terms. So instead of A, write this T equals to V minus U. Instead of T, replace it with A. So T can also be written as V minus U by T. Okay, children, so A is equals to V minus U by T, or T is equals to V minus U by A. So keeping it aside, substituting, S can also be written as U plus V by 2 into, so instead of T, I can replace it with V minus U by 2, A. V minus U by A. So again rearranging the terms, U plus V, A plus B is also equals to B plus A. A plus B equals to B plus A. Similarly, U plus V equals to V plus U. So U plus V can be written as V plus U by 2 into V minus U by 2. Children, I hope you know the formula. A plus b into a minus b can be written as a square minus b square. What is that, children? A plus b into a minus b is nothing but a square minus b square formula. A plus b into a minus b equals to a square minus b square. So here also, if you see that v plus u into v minus u can be written as v square minus u square. A plus b into a minus b, a square minus b square. V plus u into v minus u, v square minus u square. Whole upon 2 into a can be written as 2a. Can be written as 2a. So, bringing to the other side, we have v square minus u square equals to this 2a, bring to the other side. Then it will become 2as. What is the formula, children? V square minus u square is equals to 2as. Let me replace it once again. V square minus u square equals to 2as. This is the third equation of motion. What is this, children? This represents the third equation of motion. Children, if the body moves with initially with at rest, whenever the body move condition in the beginning is some rest condition, that is initial velocity is 0. When body starts from rest, so again here condition, suppose if when the body starts from rest, the body starts from rest, then the value E equals to 0. So whenever U is equals to 0, then we have V square is equals to 2AS. Whenever the body starts from rest condition, this will be 0. Hence the leftover term is V square is equals to 2AS. So children, so today I have discussed something regarding the 3 powerful equations of motion. What are the 3 powerful equations of motion? So, the first equation of motion was V equals to U plus AT. What is that? V equals to U plus AT. The second equation of motion was S equals to UT plus half AT square. What is that, children? S equals to UT plus half AT square. And the third equation of motion was V square minus U square equals to 2AS. What is the third equation of motion? V square minus U square equals to 2AS. I hope all the 3 equations are clear to you. Okay. So moving ahead, one more interesting topic, some relation between. So the body, you can say that the body may cover some particular distance in some time limit, another particular distance in some other time. But a very important, for example, if we want to consider in 2 seconds the body has covered 3 meters and in 5 seconds the body would have covered 7 meters. Then how much is the distance covered by that particular second, particular 4th second, some distance it would have covered, 3rd second, some other distance it would have, some that particular instant of time, how much distance this body is supposed to be moving, that we are going to calculate. Okay, so instead of saying 3rd, 4th, like instead of saying number, I represent that particular second as nth second. So distance moved by a body in nth second. Okay, so this is the next concept we shall discuss. Yes, distance or displacement, distance covered by a body or travelled by a body in nth second. Distance travelled by a body in nth second. Let us suppose that if Sn is the distance travelled by the body in n seconds. Instead of t seconds, I have just replaced it here with n seconds, any number of seconds. So distance, if Sn indicates the distance travelled by the body in n seconds, and Sn minus 1 is the previous time. Okay, this suppose that 7 seconds, this will be n minus means 6 seconds. This the total how much time? The previous one lower than that. Okay, distance traveled by the body 1 second before that, n minus 1 seconds. That was in total n seconds, and here only n minus 1 second. Suppose if it happens to be the distance traveled in 5 seconds, this will be 4 seconds. If this is 10 seconds, this will be 9 seconds, the total time that is given. Okay, then Snth we need to find out. Snth means distance traveled by the body in between. So suppose a body would have covered this distance in 9 seconds and this total distance in 10 seconds. This total distance in 10 seconds. Then what is the distance traveled by the body in that nth second? Nth second means this particular second. Okay, so what is that? This particular 1 second, whatever the distance travel, this is taken as nth second, children. Okay, this is n seconds, this is n minus 1 seconds, but this is nth second. That you need to understand, that particular time. So distance traveled by the body in nth second. Children, makes a lot of difference. This is n number of seconds, this is nth second. Makes a lot of difference, children. Okay, n number of seconds and nth second. Okay, so let us try to understand this. Children, suppose what is the distance traveled by a body in t seconds? We know that S is equals to ut plus half at square. In t seconds, the formula would be S is equals to ut plus half at square. Second equation of motion. Okay. If I want it in n seconds, this is in t seconds, this is the distance traveled. I want it in n seconds. Then instead of t, what is there? I'll write it like this. In t seconds, S is given by this value. Instead of t, I want it in n seconds. Then S is equals to, instead of t, I have to replace with n. un plus half a n square. So in n seconds means un plus half an square. In n minus 1 seconds means this is replaced with n minus 1. So let us try to understand properly. N number of seconds, n minus 1 number of seconds, this is that particular second. So clearly the distance traveled by n seconds is given as Sn is equals to, just a notation, okay, in n seconds, ut, instead of t, n, ut. I'll replace it here. S is equals to ut plus half at square. Okay, this is for t seconds. Okay, so S equals to, instead of t, I replaced with n, plus half a. Instead of t, I have to replace with n square. Similarly, the distance traveled by the body in n minus 1 seconds, then it is written as Sn minus 1, which is equals to u. So now instead of t, what is there? N minus 1. So you have to replace with n minus 1 plus half a. Again this u as it is, instead of t, n minus 1 plus half a. Again instead of t, n minus 1 whole square. Clear, children? So this is the case. Now what I would like to find out is the distance traveled by the body in nth second. Not in 10 seconds, not in 9 seconds, in between. Not in n seconds, not in n minus 1 seconds. In between is called as nth second. So nth second is whichever is more, just go through. This is highest and this is largest. Difference between these two is nothing but un plus half an square minus, so distance in the nth second is nothing but distance traveled by the body in n seconds minus distance traveled by the body in n minus 1 second. So this whole minus u into n minus 1 plus half a into n minus 1 whole square. So Sn minus Sn minus 1. So after simplification, it can be written as un plus half an square minus u, take it inside, un minus u plus half, this is of the form a minus b whole square. A minus b whole square can be written as a square plus b square minus 2ab. A square n square plus b square 1 square is 1 minus 2ab, 2 into n into 1. How much is that? 2n. Now let us try to open the brackets, children. Then you are left with, let us open the brackets, un plus half an square minus, take it inside, minus un. This minus and this minus will become plus, u minus and plus will become minus, half into n square is half n square, minus and plus is again minus, half into 1 is half, and again minus and minus is plus, half into 2n is 2 gets cancelled, this will be n. Is that clear, children? So this minus un, minus and minus plus u, minus and plus minus half n square, minus and plus minus half, minus and minus plus half into 2n is n. Okay, children? So this, after further simplification, plus un and minus un gets cancelled. Isn't it, children? So based on that, let us try to simplify. And here also, if you observe that this is half an square is there, and 1 second, children. So here half a is there, this a also we need to multiply this a here, and here also a. Then what you are left with? A, and here also let us write it as an. Okay, children? This a into n is an square. Okay, and next this value into a, and here 2n into a is a. Okay, so a I replaced. Half an square minus half an square cancelled, plus minus half an square plus half an square. Then what is the leftover, children? What is the term that is being left over? Equals to, this is u, this is plus an, and this is minus half a, is the value of Sn. If you observe these two, what is common here? An is here, half a is there. So a is common. So let us try to take out a as common. Then you are left with n minus half. What are you left with? U plus a is taken common. Here you have left n minus, this is half. So Sn is equals to u plus a into n minus half. LCM, take the LCM, children. If you take the LCM, how much it will be? This will be u plus a as it is. Here it will be 2n minus 1 by 2. What is that? 2n minus 1 by 2. So this 2 you bring here, then how much it will be? Hence the value of Sn is equals to u plus, bring the 2 outwards, a by 2 into 2n minus 1 by 2. Half 2n by 2 is 2n by 2 is, so 2 I brought it outwards, then what are you left with? A by 2 into 2n minus 1. So what is the formula, children? Children, don't worry, you can only remember the formulas, not the derivation part. No one will ask you for derivation. Okay, Snt is equals to u plus a by 2 into 2n minus 1. So 4 equations I have discussed till far. What is the first equation of motion, children? The first equation of motion was, what is that? V equals to u plus at. V is equals to u plus at. Second equation of motion was S is equals to ut plus half at square. S is equals to ut plus half at square. Third equation of motion was v square minus u square equals to 2as. What is that? V square minus u square equals to 2as. Apart from that, we also tried calculating the equation of motion based on the nth second, that particular instant of time. And the formula for Snt is given by either this, that is u plus a into n minus half, or after taking LCM, you can also write it as u plus a by 2 into 2n minus 1. What is that? U plus a by 2 into 2n minus 1. These 4 equations you like to remember so that you can apply for the further numericals. Children, one more thing I would like to discuss is something regarding the braking time. Suppose that a person, you're driving a car, okay, you're going by a car, and suddenly whenever you're traveling on the main road, okay, highway, suddenly a boy crosses the road. So what happens? You have to. So earlier you were not aware that the boy is going to cross the road. So all of a sudden the boy crosses the road. Then immediately that you will be observing. You have to observe that the boy is about to cross the road. So what you have to think? No. So this boy is crossing the road. I have to apply the brakes. Then your brain starts thinking. Then the brain will give instructions. Instruction that you have to apply the brakes. Okay. So what was trying to tell you is, so the boy is about to cross the road. We have to think accordingly, and then you have to apply the brakes. Meanwhile, some small amount of time is being covered, isn't it, children? This time gap is called as your relaxing time. Okay. So let us discuss in detail with the help of numericals in the later sessions. Okay, children.